Alright, hi everybody. I hope you're all doing well. So I put together this little video, and what this video is going to be, it's just going to be a way for me to communicate what we've done, where we're going, and then it also allows me to introduce some new vocab that it's going to be really important for the first week. So, I have broken stats up into two parts. The first half of stats is pre-corona, before we went on break. Second half is going to be post-corona and what we're going to cover after break. So, first part of break, what we did is we graphed one variable data, graphed two variable, it says date, you should say data. Let's change that. Graph two variable data. So what we've done, the one variable data, that was our histograms, our dot plots, our box and whisker plots. Our two variable data was the correlation, two variable data, that was the scatter plots. And what we looked at with the scatter plots is correlation coefficient. And what that tells us is how closely our two variables are related to each other, how much they correlate. So if we remember, that number was between 0 and 1, and the closer you are to 0, the more they don't relate to each other, and the closer you get to 1, the more they do. And then right before break, the last thing that we were doing was linear models. That was the formula y equals a plus bx. And what this has allowed us to do is it allowed us to make some predictions based on our information. So what we're going to be shifting more towards is we're going to be looking more now at experimental design. So what we've been doing the first half of the year is we've been really looking at how to analyze data. Now what we're going to do is we're going to kind of think about how can we start to design statistical experiments. While doing that, we're going to learn about types of experiments. We're going to learn about some sampling methods and what that means. And we're also going to look at some biases and how the design of an experiment could potentially lead to bias and how we can try to avoid bias. And then at the end of all of this, what we are going to end up doing is making your final project. Your final project is going to be the big end of the year for us. It's going to be the project that really assesses all of your learning that you've done for me. And it also is going to tie what we've done in the first half and the second half together. So I'm looking forward to that. That'll probably be the last three and a half weeks of our online learning. So what I want to do right now is introduce you to 3 new words. These 3 new words will be super important in our experimental design unit. And these 3 words are population, sample, and bias. So these words you need to have written down somewhere. They are essential in what we are doing moving forward. So with that being said, what I'm going to do is I'm just going to go over the 3 of them, and then after we're going to look at an experiment, and we're going to try to identify all of this. So, population. Population is the entire group of items in which samples can be drawn. Actually, what we're going to do, I'm just going to read all the definitions, then we're going to go over, because I think that's going to kind of make some clarity. The sample is a relatively small proportion of people who are chosen in a survey to represent the population. So the soup example, what I mean by this is, let's say we have a giant pot of soup, and we're making it, we've been working really hard all day, and we want a taste test just to see how it tastes, right? So what this does a good job of, what a normal person would do, is they'd take a spoon, dip it in the soup, and they'd take a taste test, right? So this is a great analogy for how population and sample relate. So in this example, the population would be the whole thing of soup. And what we're doing is we're just taking a small proportion, that spoonful of soup, and we're going to taste it to see what the whole batch of soup is like. So the sample is a group of people that we study in our experiment that represents a larger group, which is going to be our population. And then finally, the last word is bias. And a bias occurs when the sample does not accurately represent the population. So we're going to do a quick example just so you can kind of see more what it looks like in the stats world And then you're going to get some practice this week with identifying population and sample and starting to recognize bias. So the example says Mr. C is designing an experiment. He wants to know the average number of hours of sleep a senior at BFA gets a night. He decides to survey 20 seniors who are randomly selected from all the senior athletes. We plan to survey them by He plans to survey them by emailing them a survey. What is the population and what is the sample? So, what is the population? The population is what? Let me say anything about that. Well, I hope you've taken a second to think about this. So the population is the group we're looking at as a whole. So in the soup example, it was the whole thing of soup. And in this, what we care about, is the seniors at BFA. We're looking at how much sleep they get. So our population would be the seniors at BFA. Then we need to go to the sample. So in that soup example, what the sample was the spoonful of soup that we tasted just to see how the whole batch was. So in this case, what did I do? What did he do in the experiment so that he could break it down? So it's a smaller group of people he was surveying. He took 20 seniors who were randomly selected from the senior athletes. So our sample is the 20. It's not 20. It's the 20 randomly selected senior athletes. So what do you notice here? What is our population? Our population is the seniors at BFA, where our sample is 20 randomly selected senior athletes. So the final question says, is there a bias? To me, this screams yes. Here's why. Our sample needs to accurately represent our population. Here's why it doesn't. What we took is we took a sample of, here, let me rephrase this. So what we did first is our overall population is the BFA seniors. What we did is we broke apart the seniors into groups. We broke them apart into athletes and non-athletes, right? And we chose only from the athlete side. So because we didn't choose all seniors, because we didn't randomly select from all seniors, that we would probably expect some sort of bias, because we know that depending on people's schedules and what they have going on in their lives, we may not get the best results we need. So we just need to be careful of bias here. So is there bias? Yes. The sample does not accurately represent our population. He chose to survey athletes instead of all. Oh my goodness. All of the students. At BFA. So yeah, that's a quick little example of this. I think that with a little more practice, I think you're going to really start to be able to pick up on this. And the next few weeks, we're going to really learn a lot about how to create an experiment in the statistical world. Bye, everybody. If you have any questions, please do not hesitate to reach out.